Welcome friends to my YouTube channel. Now on yesterday's lecture, I have told about the moment of inertia of a circular disc about an axis passing through the center and perpendicular to the plane of the disc, and also I have discussed the case about the diameter and also about an axis parallel to the diameter. So I have discussed different things. Now on today's lecture I shall going to discuss the moment of inertia of a solid cylinder. Okay, moment of inertia of a solid cylinder. Okay, the moment of inertia of a solid cylinder. Okay, so at first we are going to discuss about its own axis, about its own axis of symmetry. Okay, that is about its own axis. Fine. So just we draw a cylinder. Okay, just we draw a cylinder. Okay, now if we assume that the radius of the cylinder is r and its length is l, okay, so the cylinder is composed of large number of discs, that we know obviously that this cylinder is composed of large number of circular discs piled one above the other. Okay, that means this. So the radius of the cylinder is equal to the radius of the circular disc. Okay, so the moment of inertia of the solid cylinder about its own axis will be the sum of moment of inertias of such disk about the same axis. Okay, so solid cylinder consists of large number of disks piled one above the other. Okay, so we take a disk of say mass m and say radius r. So what will be the moment of inertia of such a disk of mass m, okay, about an axis or about its own axis? That we know that half m r square. Okay, so this is the moment of inertia of a circular disk about its own axis. Okay, that is the axis of rotation. So if we take summation of this, we will get the moment of inertia of the entire cylinder about its own axis of symmetry. So the result will be half capital M r square. That is, capital M means this, the entire mass of the cylinder. Okay, so at first this is the expression about its own axis of symmetry. Okay, now let us discuss another case. Okay, that is the if we change the axis, then the result will be different. Okay, now we are going to discuss about an axis that passes through the center of gravity and perpendicular to the length of the cylinder. Okay, this is the axis, or you can say the length passing through the gravity. That means the axis is taken in this way. Okay, the passing through the gravity and perpendicular to the length of the cylinder. Okay, or perpendicular to the own axis of symmetry. Okay, so Again, we know that the cylinder is composed of large number of circular discs, okay, piled one above the other, and we consider such a disc. So if r is the radius of the cylinder, then it will also be the radius of the disc. Fine. Okay, now the disc is taken at a distance x from the center of gravity of with dx. Fine, just look up. We choose the disk at a distance x from the axis of with dx. Fine, and here r is the radius of the cylinder, that means radius of the disk is also r. Okay, so disk is taken at a distance x from the axis whose width is dx. Okay, now also the radius of the disk equal to radius of the cylinder equal to r. Radius of the disk, this is equal to radius of the cylinder. Fine. Okay, now we have to find out the moment of inertia about the axis AB. So what will be the moment of inertia about the axis AB due to the elementary strip? At first, if we take it di, then first moment of inertia about the diameter, okay, that means 1/4 mr square. 1/4 m is what? If we take rho is the mass per unit volume, then its area is if rho is mass per unit volume, then pi r square rho dx, this is the mass. Okay, because rho is mass per unit volume and pi r square dx is the volume. Okay, so 1/4, this is the mass, this is this. Okay, okay, this is the moment of inertia about the diameter, that is 1/4 m r square, and m is what? Rho is mass per unit volume. Okay, so what will be the volume? That is pi r square dx into rho. So this is 1/4 m. Okay, and r square means this. Okay, now plus mass into distance square. Distance square, what is mass? That is pi r square dx into rho into x square, according to parallel axis theorem. Moment of inertia about AB, that means moment of inertia about the diameter plus mass into distance square. Okay, so what will be the moment of inertia due to the whole circular cylinder, whole solid cylinder? The axis is taken midway, that means if total length is L, we have to integrate this minus L by 2 to plus L by 2. Okay, so the result will be this 1/4 pi r square rho, this is minus L by 2 to plus L by 2 dx, and this is pi r square rho, this is x square dx, simply minus L by 2 to plus L by 2. Okay, so this is simply 1/4 pi r square rho, this is simply L. Okay, and this is what? Pi r square rho x cube by 3, that means 3 x cube, that means L cube by 8 plus L cube by 8. Okay, so this is simply 1/4 pi r square rho L, okay, plus pi r square rho L cube. Okay, this is 2L cube by 8, that means L cube by 4, that means this 12. Okay, Okay, so this is the result. Fine. Now if we simplify it, what would be the result? That is, if we take pi r square rho l common, okay, pi r square rho l well, pi r square rho l, if we take common by 4, we can also take this common. Okay, so the result will be this. Okay, so this is the result. M by 12 L square, m into L square by 12 plus r square by 4. So this is the moment of inertia of a solid cylinder about an axis passing through the center of gravity and perpendicular to the length. Okay, I made a mistake, there will be r to the power 4. Okay, so if you, where m is what? Pi r square L rho. Rho is the mass per unit volume, so pi r square L will be the volume. Okay, so this is the mass of the cylinder. Okay, so in today's lecture we shall find the moment of inertia of a solid circular cylinder. Okay, so dear guys, if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, thank you.